Hello students, welcome back to the 10th video of this playlist. In this video, we will be solving question number 10 from the recent past paper of Pure Mathematics 1, which is the October 2023 P1 paper. So let's get started with question number 10. Right at first, we can see a figure number 4, the fourth figure of this paper. So figure 4 shows a sketch of the part of the curve C1 with equation y equals 3 cos x over n degree, where x is greater than or equal 0. So the curve C1, we can see it is on the positive x-axis, where n is a constant. The curve C1 cuts the positive x-axis for the first time at point 270 degree 0, as shown in figure 4. So point P, it is the curve C1, it is intersecting the positive x-axis for the first time at 270 degree, x coordinate 270 degree, y coordinate 0. Fine. So part A1, it's asking to state the value of n. The value of n. Okay. So how can you figure out the value for n? It is basically using the x coordinate of point P. We know that, okay, at first consider the curve, the trigonometric ratio. This trigonometric ratio, it's cos theta, the graph of cos theta. So cos 0 degree, it's 0, 90 degrees, cos 0 degree is 1, 90 degree is 0. But here, so basically in the graph of cos x at x equals to 90 degree, you will see that it is intersecting the x-axis for the first time. Yeah, positive x-axis for the first time, but here it is intersecting at 270 degree. That means the x coordinates are getting multiplied by 3. Okay, so that means this is horizontal stretch, and for horizontal stretch always the opposite thing happens. So therefore we need to divide by 3, divide x by 3 within the bracket of the function. So that means here the value for n should be 3. So for part A1, the value for n is 3. That's it. That's what part A1 has asked for. Fine. Okay, next is part A2. Here the question is asking to state the period of C1. Okay, we need to state the period of curve C1. Okay. So what we know? We know that for the curve C1, all the x coordinates are getting multiplied by 3. That means the period will also get multiplied by 3. So the period of the graph of cos x, it is 360 degree. So in this graph, the period will get thrice. It will get tripled. Okay. So 3 times 360, it is 1080. So the period of curve C1, it is 1080 degree. That's it. That's the period of curve C1. That's it. Fine. Okay, next is part B. In part B, the question says the point Q shown in figure 4 is a minimum point of C1. Okay, let's see point Q. This is basically the point Q. So this is the second minimum point. This is the first minimum point. This is the second minimum point. Okay. So the question in part B, it is asking to state the coordinates of Q. Okay, we need to state the coordinates of point Q. So we can see that point Q is the second minimum point on the curve of C1. So let's consider what's the x coordinate of the second minimum point in the graph of cos x. So cos 0 degree is 1, 90 degree is 0, 180 is minus 1, 270 is 0, 360 is 1, and then 450 it is 0, and 540 it is negative 1. So at x equals to 540, there is the second minimum point on the curve cos x happens. So the first minimum point, it is at x equals to 180 degree, and the second minimum point, it is at 180 plus 360, which is 540 degree, because the graph of cos theta repeats up after each 360 degree, right? So that means we know that this is for the graph of cos x. This x coordinate we got, it is for the graph of cos x. If the curve C1 it was the graph of cos x, then x coordinate at point Q would be 540. But this curve, it is horizontally stretched, right? So x coordinate will get multiplied by 3. So 540 times 3, that would give you 1620. So for part B, coordinates of point Q, it is 1620 degree, and y coordinate would be -3, since it is the minimum point. Minimum value of cos x, it is -1, so -1 times 3, there is a coefficient 3, so that would give you -3 y coordinate of point Q. That's what part B of question number 10 has asked for. Fine. Okay, next is part C. So here the question says the curve C2 has equation y equals to 2 sine x degree plus k, where k is a constant. The point R with x coordinate a, y coordinate 12/5, and the point S -a, x coordinate -a, y coordinate -3/5, both lie on the curve C2. Okay, given that a is a constant less than 90 degree, so part C, it's asking to find the value of k. Okay, so we need to figure out the value of k. So coordinates of 2 points that lies on the curve C2 are given. Okay, so for part C, we will use these 2 coordinates to figure out the value for k. So the equation of curve C2, it is 2 sine x. So the x coordinate is a, so 2 sine a plus k, it is equals to 12/5. This is the first equation as we substitute the coordinates of point R. And second equation, it is 2 sine -a plus k, it is equals to y coordinate -3/5. Okay, so we need to figure out the value for k. Okay, let's have a look. We got 2 equations. Since a is an acute angle, that is a is less than 90 degree, so we know a formula that sine theta is equals to negative theta, it is equals to negative sine theta. Why? Consider the cast diagram. In the cast diagram, CAST, so consider theta. Theta is an acute angle, so it lies in the positive x-axis, right? So if you consider negative theta, it is what? It should be considered clockwise. So now it lies in the 4th quadrant where sine theta is negative. That's why we can write negative of sine theta. Okay, so this is equation 1, this is equation 2. So wait, let's write the equation. Let's simplify the second equation. So -2 sine a plus k equals to -3/5. This is equation 2. Now what we will do, we need to eliminate a. We just need the value for k. So add the 2 equations, 1 plus equation 2. So -2 sine a, positive 2 sine a cancels out, so you will get twice of k equals 12/5 minus 3/5. So 12 minus 3, it is 9/5. So the value for k, you will get 9/10, that is 0.9. So the value for k, it is 0.9 or 9/10. That's it. That's what part C of question number 10 has asked for. Fine.